Welcome to this video on lesson 7 of the Earth and Climate scheme of work. This one is the penultimate lesson on the rock cycle, and really the final lesson where we introduce anything new in the rock cycle. And this one's on metamorphic rocks. So it's worth starting, as with all these lessons on the rock cycle, with the rock cycle itself. And again, there's a slide with a diagram of the rock cycle, or you can use your own like I've got here. So we've talked through these three stages from the formation of igneous rocks through magma rising, how rocks get broken down, how we then get the sedimentation, compaction, cementation to form sedimentary rocks, and why fossils are often contained in sedimentary rocks. What we're looking at next is the final class of rocks, which is metamorphic rocks. And I think what my diagram is missing here, which I could maybe add now, is the fact that the mantle exists underneath the crust. So we've got the mantle here, and firstly the mantle is heating, so it's a lot hotter than the crust. Therefore these rocks that are buried deep underneath the Earth's surface are getting heated, and there's some deformation happening because of that, because of this high temperature that they are placed under. And then the other thing that's happening is you're still getting these movements of the mantle. So I could show the mantle moving this way or maybe this way. It depends. If we've got a constructive plate boundary here, then the mantle's likely to be moving that way. And what we're getting is these kind of forces that are twisting and contorting the Earth's crust, and taking the existing rocks, whether that's some granite that's been formed down here, let's say, whether that's sedimentary rocks that are formed down here. It's taking those rocks and it's either squashing them further and changing their chemical composition like that. It's twisting them and contorting them and giving them these kind of wavy bands that I've drawn here. There's lots and lots of things it can do. Really, the main takeaway from this lesson is it's about intense heat and pressure. That's the kind of key phrase that we want students to take away. And then we want them to be able to look for the features. So as in the previous two lessons on igneous and then sedimentary rocks, what we're going to do first is just have a look at some samples. So I think a good one to start with is this one. And actually, you can get students to have a look at this, and straight away, before you pardon me, explain anything about how this is formed and what it's called and so on, you could ask them to identify whether this sample, and I'm sure you'll have a similar sample in your prep room, whether it comes from an igneous or a sedimentary rock. And what you're hoping students are looking for is that they'll see these layers, and hopefully you can see the layers through my hand lens here, but they'll see these layers and they'll identify that, well, hang on, this is probably just some sort of sedimentary rock that's been squashed together. And that's what it is. It's just mudstone. So that's layers of mud that have been crushed together, that's been kind of squashed and heated even further under the intense heat and pressure from the mantle and movements in the mantle. And this forms slate. So this is kind of, yeah, a very famous and very kind of, what's the word I'm looking for? Familiar, I suppose. It's a very familiar metamorphic rock because it's often used in roofs and things like that. So slate would be one. You could contrast this with something like this. So this is some schist. And again, what you can spot straight away as you turn this over, if I try and get it in focus, this looks a lot more like granite or something like that. And they'll see it's a lot shinier. That's something that you quite often see in metamorphic rocks. That intense heat makes kind of, you end up with shinier crystals and things like that. So this was probably formed by an igneous rock, and you can see it's got sort of maybe some layers or kind of bands, but it's not very clear. Whereas contrast this with this one, so you can see this one. So this is gneiss, not spelt like N-I-C-E, but spelt G-N-E-I-S-S. And actually you can see some quite distinct layers. So this is where it starts to get confusing because it's quite shiny. That's quite obvious from turning it over. It's quite shiny, but actually it does seem to have these layers. And this is, but they're not kind of neat layers like in slate. They're kind of slightly wavy bands. And this is, again, due to that intense heat and pressure, and especially that pressure squashing igneous rocks together and kind of pushing the crystals into layers, and then sort of folding them slightly to make them a bit wavy. And the last one you could show them is something like this. This is marble, and this is again, you can't see any layers here. It is shiny, but when you look at it, it actually looks more like one of the sedimentary rocks. So and now I've realised I haven't done my homework. In fact, maybe let me look in here. What's this formed from? Yeah, this is from limestone. So this is formed from a sedimentary rock, and it's actually formed from limestone. But again, through that intense heat and pressure, the minerals in the limestone have become shiny. So there's just a few examples and the kind of things you can get students to look out for. And again, this is where it's a bit more complicated, and you can sort of give them some reasonable rules of thumb, but with metamorphic rocks, it's a little bit less distinct. So what we're going to do here is just illustrate how these metamorphic rocks are formed, and we can just zoom in on the rock cycle. In fact, I'm not sure we even need to zoom in on the rock cycle that much. We can just show from the rock cycle here. But essentially, what we're going to illustrate to students is that because of these movements of the mantle and the heat from the mantle that we've talked about before, that's why you are changing the chemical composition of these rocks, and you're also changing the kind of way they're organized, whether that's with slate, where you're squashing the layers together even more firmly, or with, for example, the banded gneiss, where we saw the kind of slightly wavy layers of crystals. And the point that students need to remember is that it can come from either. It can come from the igneous rocks, or it can come from the sedimentary rocks. Either can be metamorphized, and you could go into the etymology of that word and what morph means change, and meta means beyond, so it's kind of changing beyond their original form, to say that's what happens. And that essentially then completes the rock cycle, because the last thing that can happen is that if the mantle is moving in a certain way, it can actually just draw these metamorphic rocks back into the mantle and melt them completely, and then the cycle starts again. So then they become magma, and then they can rise up and start all over. And remember, the aim of this sequence of lessons, if I just get the whole rock cycle back up, is that students will be able to relate all of these different parts of the rock cycle to one another, and that's really going to help them build memory, because rather than just trying to get them to remember specific unrelated points, we're trying to put all of those points within a system, and that's really going to help them. So it's what we want from this sequence of lessons is that they have this picture in their heads, and that's what we're going to focus on in the next lesson, which is turning this into a piece of extended writing where they kind of cover everything in the rock cycle together. The one last thing I should have said, there's a few examples in the slides where students are looking at rock formations. So, when you're doing the rock samples and you're looking through the hand lenses and so on, and you're talking about intense heat and pressure, we tend to look at a kind of very micro level, so at the level of kind of one individual rock, like this, what's this, the schist, whereas actually a lot of geology is looking at larger rock formations. And there's some examples that you'll see of kind of mountain ranges where you've got obvious layers of sandstone, and you can see those layers in there, or chalk on the Dorset coast. You've also got some structures where you've got these kind of wavy bands, or this kind of large-scale folding, where existing layers have been squashed by the intense pressure and the movement of the mantle and deformation of the crust and so on. And so part of this lesson as well is not just focusing on the micro of individual rocks, but it's also looking at the macro of how these forces can shape the landscape around us, which is another key part of geology, and about this broader point about earth science, which is using our observations and the evidence in front of us to understand these forces that are going on underneath the Earth's surface that are shaping the world around us. So yeah, you'll see some questions on that in the slides as well. So in the next video, which is the last one on the rock cycle, we'll look at this piece of extended writing, bringing all of this together, and then we'll be moving on to the carbon cycle.